Now let's look at the most interesting type in Solidity, the mapping type. You can remember that mappings are kings and you will use them all the time. In this lesson, you will learn what they are, why they are so useful, how to actually use them, and all the sometimes surprising details you need to be aware of. You can think of mapping as a table. Wait, what? A table? No, not that kind of table. The other one. Ah, yes, this kind of table. In the normal case with one column, you will very often see a mapping which maps from the address type to some other type. This is generally a pretty common and efficient way to store values for a specific user address. For example, here we are storing some points for user addresses. So how exactly do they work? Mappings are sort of like hash tables, if you are familiar with those. But they are slightly different from hash tables, as we will discuss at the end. So what is a hash table? Well, in essence, it's a structure that can map keys to values and uses a hash function for storing values. Okay, so keys to values, that's the key part here, no pun intended. And when you are looking for a value, the key is hashed, and the resulting hash indicates at which storage address the corresponding value can be found. Okay, so take this example here. Here, the 06F address would be mapped to the 7BF key. Basically, you are calculating the Ketchup 256 hash of the 06F address, and the result is the 7BF key, which will then be used as inputs towards our key value table. The Ketchup 256 hash function is the hash function which is available as part of the Ethereum virtual machine, the EVM, if you remember. And don't worry about how that hash function works under the hood. Nobody knows. Okay, I'm kidding. Some people know, but it's complicated cryptography and you don't really need to know this. So, what is the advantage for all of this? Well, it allows for very efficient storing and reading of data. Imagine you want to write the value 2 for the A16 address. With a hash table, storing the value is a quick two-step calculation. First, calculate the hash, which will be 12D, and then write the value 2 at the storage address 12D, which is the hash we just calculated. And likewise, retrieving the value is a quick two-step calculation. Again, first calculate the hash, and then instead of writing, you would read the value at the storage address 12D. If it was previously set, it will, for example here, return the value 2. This is all much more efficient than, for example, storing and reading values in arrays. If you are looking for a value inside an array, you don't know where it's stored. So in our previous example, we would look at the first element and it's not the address we were looking for. Then the second, no, still not. Then the third, again, still not. And then to the last element, and we would see it's the one, this 12D we were looking for. So you indeed might have to go through the whole list before finding the value you're looking for. We will talk about arrays in Solidity at a later point, because sometimes you have to use them, but in general, you should try to use mappings as much as you can. Saving gas is very important. And just remember, mappings are indeed kings. Please use them, and the good news is you don't need to concern yourself too much about the details on how mappings work internally if you just want to use them. You can also have a mapping that maps to another mapping. While that may sound confusing, if you imagine it again as a table, It just means we have multiple columns, not just two. Here, we are mapping an address combined with a Boolean to a number. And this way you can actually store two different values depending on the Boolean parameter in the table. For example, you could store two different points for users depending on the role in the contract. They could collect points as a seller or as a buyer, indicated by the Boolean. And as you can see, some addresses may be mapped to only one of the two, like A16. This address has 42 points as a buyer, but no points as a seller. Other addresses could have points for both roles as well, like B4E, which has 2 seller points and 15 buyer points. Another thing to know is Solidity will automatically create getter functions for your public mappings. If you have a public mapping from address to uint 256, you will automatically have a public view function of the same name generated by Solidity. So, for example here, you don't have to create this myMapping view function. Simply declare your mapping as public and Solidity will auto-generate it for you. And lastly, one quick note that mappings can only be inside the storage of a smart contract, never inside memory. So they cannot be parameters or return values for public functions, but you can pass them as function parameters to internal functions if you want to. Now, so far all we discussed is pretty much identical to a hash table. So what the hell? Why aren't we just calling them hash tables then? Well, let's discuss the differences in the next chapter.